Hello, Malmo. Øredev, how are you doing? So, let's have a fun talk before lunch. You'll learn stuff, it won't be useful, but it's interesting. If you want to connect with me, ask me questions, any of that sort of stuff, I'm on bluesky@rendle.dev. If you want to argue with me or debate me, please reach out on Twitter, because I've stopped using that. Because screw that guy, and screw everything, actually. Anyway, so yes, this is how JavaScript happened, and if you want to read into that, the kind of, and how can we stop it from happening again, then I'm not going to stop you. But that's obviously, you might think that I couldn't possibly comment. I will say, I found this while I was researching this talk. This is Flon's axiom. There does not now, nor will there ever exist a programming language in which it is the least bit hard to write bad programs. And I know that's true because I've written terrible programs in Haskell. So, yeah. Anyway, there were times when we didn't have computers, which just sounds awful. Although actually sometimes it's kind of like, yeah, no, I can see why. And in the 19th century, this young lady, this is Ada Lovelace. And Ada Lovelace was the daughter of the romantic poet and one-man syphilis incubator, Lord Byron. And Ada's mum thought the best thing she could do for her young daughter was keep her the hell away from her dad. And so she got her tutors and tutored her in maths and philosophy and all the things that accomplished people in those days learned. And Ada, when she grew up, went to salons. And salons were the kind of 19th century equivalent of this. People all got together and went, this is what I've been working on. Oh, isn't this interesting? And that sort of thing. And at one of these salons, she met Charles Babbage. And Charles Babbage had a design for a mechanical computer, and the British Parliament gave him money to start building it. And he started building it and then got halfway through and had a better idea, which I think we can all identify with that. But anyway, he and Ada became friends, and he explained it all to her. And there was a guy who wrote a book in Italian about I think it was the difference engine, might have been the analytical engine. You'd think, having done the research, I'd know. Anyway, and then Ada said, oh, can I translate that into English? And he said, yes, and so she did. And while she was doing it, she added some thoughts and corollaries and comments of her own. And one of the things she did was she devised a program for calculating Bernoulli numbers, whatever the hell those are. And this is her notation for how to set up the engine to run that program. So this is the first computer program. And she designed the notation herself and everything. And then nothing happened for the next 90 years. That was it. Babbage never finished any of these machines. You can now see working ones in British museums. They've built them from the designs. And that Bernoulli numbers program, that runs. It works. So that's like, 100 years, like 200 years later nearly. But then nothing happened. And then we decided we should have a war. And wars are brilliant for technology. So much technological advance has happened because we wanted to kill some other people. And one of the important things in a war is you're saying, everybody meet here and throw bombs at those people over there. And you don't want those people over there to know that you're going to do that. And so you have to use encryption to encrypt your messages. And so this is an Enigma machine. And the Enigma machine has billions and billions of possible combinations of starting positions and patch cables and all this sort of thing. And the Germans thought this was uncrackable. And the Polish went, ha-ha, and they designed the bomb. And then they passed their designs over to the English, the British, and we at Bletchley Park built multiple of these machines, and they could just chonk through the possible combinations until they got something that resembled German. And it was made easier by the fact that the first message of every day was a weather report, so it just had to look for words like rain or sun or whatever. Also, there was that one guy who signed off all his messages with hail thing. And so he helped. Cheers! Weirdly weirdly pathological Nazi dude. So yes, and despite the fact that the Germans thought this was uncrackable, and it was a terrible thing because we decoded some messages, but we had to let them do whatever was in the messages, because if we'd just foiled every plot, they'd have gone, they're reading our texts. So the German High Command, though, their messages were even more important and secret. And so this is the Lorenz cipher machine, and this has trillions and like hundreds of trillions of possible combinations. It's absolutely ridiculous, completely uncrackable. No, this is Colossus. This was built by a man who built telephone relays and switching stations for the post office in Britain, and his skills and Alan Turing and a bunch of other very clever people, they built Colossus, which was the world's first programmable computer. And then, when the war ended, they smashed it to pieces and hid all the records, and we only actually found out about this again in the 1990s. Nobody knew we had built this, which means until the 1990s, people thought the world's first programmable computer was this, the electronic numerical integrator and computer. And these are the programmers of the ENIAC, and it was programmed by patching cables between sockets. And, this was how you got it to do stuff. What I find incredibly fun about this is that the guys who built the computer didn't document any of it. Yay. And the women who programmed the computer, because it was women, because at that time, men built things from metal and stuff, and women did the easy jobs like programming. But they had to figure out how ENIAC worked by trial and error, and just go, what happens if I do this? Ooh, no. And so, yes, but these are the ENIAC programmers, Kay, Betty, Marlin, Fran, and Ruth. And it was a female occupation at first, until a bunch of bearded idiots from MIT came along and ruined it for everybody. So yes. Anyway, once we'd got that, it became a business thing. And IBM, who had been building calculators for decades at this point, launched their first mainframe, the IBM 701. And this was the first stored program computer. So you could load a program into its working memory and then run it and then load another program. And they used this for working out how to throw bombs at those enemies just in case another war started. And so trajectory formulas. And this is a very, very simple formula. And I don't have to explain this to you, which is good because I haven't got a faintest idea how that works. But that apparently will tell you where something will land if you throw it at a particular velocity. The problem was that you had to get a bunch of people who knew what all that maths meant and then were able to translate it into this, which is machine code. And very simply, it's kind of like, go, okay, what's this divided by this? And you had to write this huge list of instructions to do division, because the processors are terrible at division. And then this chap came along. This is John, I've forgotten this guy's name, and that's ridiculous. Somebody help me? The guy who created... His name's John. I'm having a complete blank. I'm old. It'll come back to me. Backus. John Backus. There we go. And John was walking along the street one day and walked past the IBM building in Manhattan, and they had the IBM 704, which was the next machine, on display in the lobby, and it had all the flashing lights all over it and everything, and he just went, ooh. By the way, those flashing lights, mostly for marketing. They were to make the machine go, oh, let's got lots of flashing lights on it. Yeah, most of them weren't actually indicating anything useful. So yes, and John Backus went inside and went, I want to play with that. And they went, well, you have to go out to HR and ask for a job. So he did, and they said, yeah, all right. And then he found out about this. And he went, oh, no, I'm not doing that. And because the thing about Backus is he was essentially a lazy man. And lazy people are very, very useful, because lazy people will find the easy way to do any job that you give them. Lazy people will spend a day writing scripts to automate something that takes 10 seconds. Yeah? And so John Backus goes, I reckon, because if I do this divided by this, it's always going to be the same machine code instructions with different values. Why can't I write a program that generates the machine code instructions? And so I went to IBM and I got this idea, we're going to translate formulas into machine code automatically using software. And IBM went, yes, all right, brand new dude who wasn't even working here last week, assemble a team. IBM in the 50s was a rocking place to work. Not so much now. Any IBM people? No. Good. So yes, he put this team together, and they wrote Formula Translator, and they went, well, what should we call it? And then Formula Translation, Fortran. And so they created Fortran. And the thing that's really interesting about Fortran is not only was it the first compiler, it was an optimizing compiler, because there were a bunch of beardy types going, well, that thing will never write machine code that's as efficient and elegant as the machine code that I write. And so Bacchus and his team went, challenge accepted. And it bloody did. So yes, Fortran, the spec was actually released in 1955. The implementation was released in 1957 of the first version of Fortran. This is FizzBuzz in Fortran. And so you can see here we've got a thing that says at the top program, and the end at the bottom is end program. And then we have a do. 40 is pointing to the line number down at the bottom there. And then we just do standard FizzBuzz. This print asterisk comma 8h FizzBuzz. So the asterisk is saying print whatever comes after the comma, and then the 8 says we've got 8 characters, and the H is something to do with the character set. And then continue drops down to, no, the continue goes back up to the do. And so this goes back up to the do, and this goes back up to the do, and then this, if it isn't FizzBuzz or FizzBuzz, we'll just print whatever I is, and then because this 40 matches this 40, it loops back up to there. So yeah. This is the original spec version of this. So the spec that they released, the multiplication character was the multiplication character, because they had the full set of things. And then someone went, oh, the teletypes that we use to program this don't have the multiplication character. And so they chose the one that looked the most similar. They chose the asterisk. And so yeah, the other thing to note from this is we say do 10, and on the previous slide as well, we've got do 40i equals 1, do 10i equals 1, and why I? So in the very first version of Fortran, there were only 2 types. There was integer and real, or floating point, but floating point hadn't been invented at that point, so it was called real. And if you wanted a variable to be an integer, its name had to start with I, J, K, L, M, or N, and any other variables were real, which led to, and then a later version of Fortran actually allowed you to declare the type, and then there was the famous joke, God is real unless declared integer. Said it was famous, I didn't say it was funny. This was the other thing with Fortran. This was how you actually loaded the program into the machine. This is a punch card. It has 80 usable columns, 80 columns where you can enter characters. Fortran didn't have line continuations, so you had to fit every line of code into 80 characters. When terminals were invented, they had 80 characters wide because punch cards were 80 characters wide. And even today, you can open up some IDEs and they are set to automatically word wrap at 80 characters in 2024 because of punch cards. Okay? So, from Fortran, we get the if statement. Fortran introduced if. We get the asterisk for the multiplication operator, and we get this tradition that continues to this day of using I as the iterator variable. Because when the Fortran programmers moved on to Algol or whatever they moved on to, they got used to using I, because it's the first one. It's the simplest one. And so, yeah, that's where we get that from. Then this chap came along. This is Edgar Dijkstra, and he very, very famously said, "Goto considered harmful." And some people have taken this as, you should never, ever, 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 ever use Goto, which is completely wrong. And I try and put a Goto in every bit of code I write, just on general principle, just to make sure people are reviewing the code properly. Is this necessary? No, but I like it. He said some brilliant things. Dijkstra is one of the most quotable people in the history of computing. This is my favorite. If debugging is the process of removing bugs, then programming must be the process of putting them in. It me! But yeah, his issue was the only way of doing flow control in Fortran was Goto and line numbers. And he was kind of like, Goto 40 doesn't mean anything. How is somebody meant to know what Goto 40 means? And so he was part of the committee that created the Algol programming language, which was a reaction to Fortran and designed to be a much more structured language. And so this is FizzBuzz in Algol. And so we begin, we declare the type, integer I, and then we say for, so we've got a for loop now, I equals 1, step 1 until 100, do. There are still programming languages that use that syntax for like loops, like Visual Basic has something similar to that. And we had strings, so the concept of strings, and we had out integer at the end there, but you could also have functions and things in Algol, and call functions and return from functions and so on. The other thing that's interesting about Algol is while he was working on the committee, when you've only got one programming language in the entire world, it's just, that's the programming language. When you've got two, then you start to look for an abstraction that can describe a programming language. And so Bacchus came up with what was originally called Bacchus Normal Form, and it was a grammar for describing programming languages and their constructs. And there was another chap on the committee called something Naur, N-A-U-R, sorry? Peter Naur. Yeah, and he sort of got together with Bacchus and went, this is awesome, can I help? And they sort of refined it together. And so BNF now stands for Bacchus Naur Form. And we still use it today. This is still the standard grammar for describing programming languages. So this is the for statement in Algol, I think. This is the iteration statement grammar for JavaScript. And so Algol gave us lots of stuff. The idea of block structure, else, so Fortran didn't have else. Algol introduced else and else if and so on. Algol also had the switch statement. It had for loops, the way we understand them today. It had functions. It was also the first language to have semicolons as a statement terminator, and Bacchus Naur Form. And Algol never really progressed beyond like a research thing. It was a theoretical playground for language designers. And there were lots of variants of Algol. And the most important one is Algol W, which was worked on by Tony Hoare, who was a British computer scientist. And Algol W is where we get the concept of null from, because Algol W had records. So you could declare a record which had references to other records, or you had a variable that was a reference to a record. And if there was no record, it's like if it's a number, you can just go 0 or -1 or whatever. If it's a string, you can just go empty string. But when it's a record, you can't have an empty record. And so he just went, we'll just call it null. Cheers for that. That hasn't caused any problems. Also in 1958, this chap, John McCarthy, was working at MIT in the AI lab, and 1958, they seriously believed that artificial general intelligence was maybe 5-10 years away. And their best estimate of how our brains work was that we have enormous lists of information and we find relationships between items in those lists. And so a programming language for AI would just be really good at processing lists. It would be a list processor, or Lisp. And so this is FizzBuzz in Lisp. And it makes sense. Lisp is quite readable most of the way through, but you can always spot a Lisp programmer because they're going, okay, 1, 1, 1, 2, 3, 4, 3, 4, 5, 6. Close, 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 close. With their parens at the end there. But the fun, so has anyone done Lisp programming? Yeah? So how do you get, what's the command to get the first item on a list? Car, yeah? What's the command to get the rest of the list? Coulter, car and coulter. So the first version of Lisp was implemented on the IBM 704. Because there was no standardization, because it was just IBM going, stuff! That we didn't have the concept of bytes at this point. We had bits, and bits were actually really expensive in these days. So yeah, the IBM 704 had a 36-bit register, or 36-bit things. And you had the first 4 bits with the prefix, and then you had what was called the decrement register, and then you had a tag in the middle, which was 5 characters, and then you had the address register. So in Lisp, the decrement register contained the pointer to the next item in the list, and the address register contained the pointer to the current value in the list. So car stands for content of address register, and coulter stands for content of decrement register. And they still use them today, even though we've gone to like 8-bit, 32-bit, 64-bit registers and everything else. This is one of my favorite examples of an implementation detail leaking into the semantics of the language. So yes, but Lisp gave us the idea of first-class functions. I can pass a function to another function. Lisp supported that back in 1958. It also, because it had these lists and it was creating lists and everything was a pointer either to an atom or to the rest of the list, so it had to have a heap. Because it had a heap, it had garbage collection. It actually had a garbage collector in 1958. It also sort of kind of did JIT, but not really, so we'll come back to JIT later. Meanwhile, Algol gave birth to something that was so different that they didn't just call it Algol 00 or anything like that. So Simula was created just over the way in Norway, in Oslo, and Simula was the first object-oriented language. And so this is FizzBuzz in Simula, and you can see we have a class printer here, which has a procedure called print, and then our code to do that is in there, and then we have a ref to print a P, and we create a new one. And the thing that's really interesting with this is you can pass in the factors and the word to show for that factor, and so this is a kind of abstraction, reusable FizzBuzz program, because why wouldn't you want to do that? But Simula gave us lots of things: classes, inheritance, polymorphism, so the idea that you could have 2 classes that both inherited from the same base class, but when you called a method on them, they would do different things. And also the idea of scope, so private, hidden, protected, internal, whatever you want to call it. And then 5 years later, Kenneth Iverson was teaching a programming course, I think it was at Dartmouth University in the States, and he wanted a programming language to use as the basis of a course. So he created a programming language, and he called it a programming language. Naming things is hard. Leave him alone. But yes, this is Kenneth Iverson. Are you ready to see FizzBuzz in APL? That's it. That's the whole thing. Yeah? Conway's Game of Life in APL is only slightly longer, and it's still a single line of code. APL was terse, right? It was really terse. Except you can, well, hang on, how do I type that character or that character and this one? This is Greek. Why is there Greek in my code? So if you wanted to write APL code, you had to buy an APL keyboard. And I don't know how much Kenneth Iverson had stocks in a keyboard company or something, but you know, if I ever invent a programming language, the keyboard's going to be the expensive bit. The cool thing about APL is it works on entire arrays at the same time. And so for that reason, it's actually still in use, although they've come up with other ways of representing those mad characters. But the other thing that APL had was dynamic typing. So you could declare an array, and you could put whatever type you wanted into the different elements of that array. So yes, dynamic typing from APL. Algol also evolved into B and BCPL and CPL. Actually, that should be the other way around. So it's CPL, BCPL, and then just B. This is FizzBuzz in B. And you can see here, we've got let start B, which is a lovely syntax, I like that. Let there be a function called start. And there was a function called start, and Mark looked at the function called start and saw that it was good. Sorry. Sometimes my brain goes and does a thing and I can't stop it. So yes, and we have curly braces. Oh, look, curly braces. No semicolons in B, though. This is weird. Algol had the semicolon. This doesn't have the semicolons, but it does have the curly braces. Problem was that most of the keyboards people were using at the time didn't have curly braces on them, and so you had to do $open paren and $close paren, which makes B look quite a lot like PHP, except dollars instead of percent signs, and, you know, multiple other templating languages. So yes, but BCPL, once we had the curly brace characters on our keyboards and people could use the curly braces, that's where we started using those. And then that, of course, B, obviously the next language is C, and so C was created in 1972. Who learned programming originally from this book? Yeah, few of you. This is the best book to learn programming from because it teaches you about stuff like how memory works and how characters are represented. I honestly believe that every programmer should learn C. And if you fancy doing it, then I recommend Zed Shaw's Learn C the Hard Way because it teaches you important stuff like Valgrind and things. But C, this book famously was the first book to have Hello World as the first program that you write. And so this is Hello World in the first version of C, in the first edition of the C book. And this is FizzBuzz in C, and you know, I'm not going to explain this. I think probably the L that I've got at the end of that line was a typo, and that should probably just be a semicolon. But apart from that, we've got a for loop, but we now have the for loop with the 3 section thing there. This came from C, and we assign a value, or we initialize some values, we run a condition against the values, we modify our values there. If there are any evil people who like C in the room, you'll know that you can write FizzBuzz as an empty for loop, because C lets you do some weird things. People love the fact that C lets you do weird things, and so this is also FizzBuzz in C. I don't know how. I really don't. I have no idea. This is an entry to the International Obfuscated C contest where people compete to see how unreadable they can make their code. Also, the people where I work. But yes, and so this is JavaScript. This is valid JavaScript, and I think this is FizzBuzz in JavaScript. I'll be honest, I can't quite remember. But you can write any JavaScript program just with combinations of dollars and square brackets and round brackets and all those sorts of things. So C gave us the C style, so semicolons and braces and all this sort of stuff, gave us hello world, and it gave us the concept of truthiness. So if you, in C, you declare a char, C, and then you can just say while C equals get char. And the compiler will turn that into, is C after calling getChar greater than 0? If it is, then that's true, otherwise it's false. And so truthiness and falsiness, and also obfuscating code for fun and profit, also known as React. In the same year as C, a much better language called Smalltalk was created at the Palo Alto Research Center at Xerox offices. And Smalltalk was created to build graphical user interfaces, the thing that Xerox famously invented and then very stupidly showed Steve Jobs. And then went, oh, can't believe he did that. But the interesting, when you have a character-based terminal, I used to write character-based things, you give the user a choice at multiple sort of points in the program, they make the choice and then you carry on. When you have a graphical user interface with a mouse and buttons, the user can click anything at different times. And so instead of having simple flow, make a choice, if this, otherwise that, you have to react to events. And so Smalltalk was designed to react to events. And so Smalltalk took object-oriented programming and introduced the idea of messages, and messages being sent. So when you clicked a button, the message would be sent a button saying it had been clicked. The guy who worked, I think it was Alan Kay, the guy who worked on Smalltalk went, I wish I hadn't called it object-oriented programming. I wish I'd called it message-oriented or message-passing programming, because that's the important bit, not dog inherits from animal. It's the fact that dog will respond to certain commands and bite people. This, just for the hell of it, is FizzBuzz in Smalltalk, and you don't write FizzBuzz as a standalone thing. You add a FizzBuzz method to the integer type, you monkey patch it, and then you just, in your loop there, you just do I, and then send the FizzBuzz message to it, and then whatever comes back from that, you send that to a display NL object, which writes it with a new line to the standard output. And yeah, if you're wondering what happened to Smalltalk, it's Ruby now. Ruby is very heavily in for the method missing, and all that sort of stuff comes from Smalltalk, and a lot of the kind of pipe syntax and everything else. This is from the Smalltalk documentation. I'm going to skip past it because we're short on time. But from Smalltalk, the main thing we got was reflection, the idea, the ability to look at all the objects and classes and everything in the code at runtime and do things dynamically based on that. But we also got console. Because Smalltalk was not just writing stuff to a terminal, they had to find a way that it could write log messages that they could read. And so Smalltalk had a console object, and you could send messages to console, and it would be displayed in a dedicated window. It was also the first language to have a virtual machine, so Smalltalk compiled to bytecode, and then it had a JIT that converted that to machine code for the architecture it was running on, and also everything being an object, which JavaScript is kind of into. Everything's an object. Objects are also functions. Functions are also objects, so everything is a function that you can call, although there's an asterisk by the JIT there, so Smalltalk wasn't actually the first JIT. The first JIT ever was in the 1960s. I think it was 1968. Can anyone guess the first programming language in the loosest sense thing to have a JIT compiler? All right, I'll show you FizzBuzz. It's regex. Regular expressions. Guy who wrote the first implementation of regular expressions in 1968 was, this is really slow. How can I speed this up? And so he generated machine code from the regular expressions. Options.compiled. Also, yes, I got that from this gist on GitHub, and this was his only comment on it. Why? Funny. I love that. On the lower end, where we got the functional languages, Lisp was it for a while, and then we got ML, which is machine language, and ML has inspired Camel, and then OCaml, and then F# and Haskell, and all these sorts of things. And so this is FizzBuzz in ML. It's quite a lot like most functional languages. The main thing we got from ML is this thing here, the equals greater than, the lambda syntax for functions, which everything these days uses. So yeah, arrow function syntax. 1975 at MIT, Abel, Sussman, and somebody else were teaching the 601 computer science course, and they wanted to use Lisp, but Lisp was really complicated by this point, and so they wrote a simplified version of Lisp called Scheme. And this is FizzBuzz in Scheme, looks pretty much the same as FizzBuzz in Lisp, and we'll talk about. So, yeah, we didn't get any language features from Scheme that went into JavaScript, but when Eichmann originally wrote Java, when you've got 10 days to write a thing, he wrote Scheme because it's really, really quick and easy to write a Scheme interpreter. You can write one in Scheme really quickly. And then he showed it to them, and they went, no, we're competing against Java. Make it look more like Java. And so the first version of JavaScript was Scheme, but with curly braces and semicolons, and yeah, it was a hack job, is what it was. And every piece of JavaScript today is backwards compatible with that hack job. So cheers for that. So then we brought together the object-oriented side, and I've put C++ as inheriting from Simula because it really didn't take any of the good stuff from Smalltalk. So it went from Simula and C. Obviously, the next language after C is C++. And this is the guy who created it. I worked with him at Morgan Stanley for a while. But yes, C# makes it easy to shoot yourself in the foot. C++ makes it harder, but when you do, it blows your whole leg off. Yeah, accurate. This is FizzBuzz in C++. And yeah, what the f is this? Why? Why are we doing... I mean, even the other way around, I would be okay. Send FizzBuzz to cout, but no, cout receives FizzBuzz. And I don't know what he was thinking. Maybe it's a language culture thing, whatever. But C++, in terms of language features, was the first language to include exceptions. So for error handling C, it was just like, if it returns 0, then it's worked. Otherwise, it'll be a number telling you what went wrong. C++ introduced try, catch, and throw, and the concept of structured exceptions. How are we doing for time? 10 minutes to go. I'm doing well. This is the entire history of programming languages, and they gave me 40 fucking minutes. I think we're doing all right. Has anyone heard of self? Yeah, one person, 2 people. Excellent, yes. I had never heard of self before I started doing this research. But yeah, so also the diagrams are generated from the D2 diagramming language. And so I added self here, and it just rearranged the entire chart. So I apologize for the confusion. But honestly, if I tried to draw these myself, it would be much worse. So yes, self was weird. It was a bit like Smalltalk, but it pulled a lot of stuff from APL, so it had dynamic typing and this sort of thing. But the thing that we really got from, and it was a completely graphical programming language. You didn't type stuff into a text window. You just kind of, like these no-code things that we're selling to people now, while we can make as much money as possible and then admit that they were shit, and we'll just go in and write software for them again. But yes, self introduced the idea of prototypal object orientation. So you didn't have classes, you had a prototype, and then when you created an instance, you just made a copy of that prototype. And so you can have an animal, which is an empty prototype, and then you can say dog, which you then say parent animal. And so when you create a new dog, it takes anything you've put in the dog prototype, but also anything you've put in the parent prototype, and the dog prototype can replace things in the parent prototype, and that sort of stuff. So self, single contribution to the world of programming, was prototype-based OOP. Thank you so much, self. That hasn't caused any problems for everybody. C++ was great. In C, when you wanted to create a struct or an array of structs or whatever it was, you had to use malloc to go, just give me some memory. C is really close to the metal. Just give me a block of memory, a contiguous block of memory if possible. And it does. And then you have to free that memory, otherwise you get a memory leak. C++ did all to help with that. It just changed the word free to the word delete, and instead of having to malloc memory manually, you just went, give me an array of that type of object, and it would work it out for you in the compiler. Java was the solution to that. So Java was C++, but without memory leaks. So garbage collection, VM, taken from Smalltalk, but most of the syntax taken from C++. This is FizzBuzz in Java. So we have a sound factory, and this isn't all of it, because there's also a sound factory manager and a sound factory manager strategy. Or is that the other way? Anyway, but yes, this is kind of as much as I could fit on the screen. I love Java. And so then all of these things came together, and in 1995, Brendan Eich, sitting in his office, I said Eichmann before, didn't I? That was like a war criminal. Sorry. So yeah, Brendan Eich very famously knocked together JavaScript in 10 days and pulled features and ideas and stood on the shoulders of all these giants and somehow still fucked it up. So not sure how that happened, but he was pressed for time. If I could invent a time machine, you know that thing, I'd go back and I would kill Nigel Farage or Donald Trump as a baby or whoever. Or, you know, how far back could I'd just like wipe out the entire Trump line before they even left Europe. That's the only way to be sure. But actually, when I was on the way back from killing Trump's great-great-grandfather, I would stop by 1994. Okay, and I would find Brendan at the Netscape campus, and I would say, Brendan, don't ask how I know this, but trust me, I know this. Next year, Mark and Ben are going to come, and they're going to ask you to knock together a scripting language to put in the browser for the version 2 thing as a demo. I just want you to know that by 2025, that will have become the most widely used programming language in the world. It will touch everything. It will be used to drive the displays on capsules that are flying astronauts to and from a space station. Yeah, the Dragon capsule, the displays in that, fucking react, honestly. So yes, we got JavaScript. But obviously JavaScript has continued to evolve, and in 1999, if you're talking about the sort of 1.0 alpha version, Microsoft created C#, which was derived entirely from C++, not influenced at all by Java. It was entirely coincidental that it had a virtual machine bytecode and a JIT. It was taken from C++. Obviously, the next version of C++, next version after C++ is C++++, and then if you put the two pluses under the other plus, then you get a hash symbol. C#, not related to Java at all. No, that's basically a lie. I did this talk with Mads Torgersen in the front row in Copenhagen last year. That was fun. He laughed. It was good. But yes, C#, the thing about C# though is, yes, it was a clone of Java pretty much at the start because Microsoft tried to make Visual J++ and then J something and some went, no, you can't do that, that's ours. Bugger off, it's not open, because it wasn't at the time. And so Microsoft went, right, we'll just pretend we've invented it. And they called it C#. But C# has introduced lots of language features along the way, such as async and await, and that has made its way into JavaScript as well. And the field of programming language research is busier than ever. People are coming up with new languages. We're getting things like Eiffel for contract-driven development, Zig, V. There's all sorts of stuff going on. And the nice thing about JavaScript is it just kind of goes, oh, that's a nice feature. Let's have that. The bad thing about JavaScript is while it's pulling in all these new features, it still, to this day, has to remain entirely backwards compatible with all the crap that Brendan chucked in the first version, and including type coercion. JavaScript did not get type coercion from anywhere. That was original and a really bad idea. But yes, so that is my little talk, and I'm just going to go back to the opening slide there. We have done the entire history of programming languages back to, because the last slide is a closing slide for the last time I gave this talk, and it says goodbye to the wrong conference. Because I suck, and I'm sorry. I love you, Øredev. I have no idea how to pronounce it even. You'd think I would have worked that out. So yes, that was how JavaScript happened. Please use that knowledge and avoid creating JavaScript again in the future. Like I say, I'm on Blue Sky, Rendle.dev. I'm around for the rest of the day. I'll be around tomorrow morning if you want to come and talk programming languages. The last thing is people generally come up to me afterwards and went, why wasn't Pascal in there? Why wasn't COBOL in there? Why wasn't Python in there? Why wasn't my favorite programming language in there? The only languages that are in there are the ones that innovated features that are used in JavaScript. Yeah, JavaScript doesn't use significant white space, so we don't have Python. Pascal didn't innovate anything that wasn't also innovated in C 2 years earlier, and you can actually put in macros in C that changed open brace to begin and close brace to end, and equals to colon equals, and equals to just equals. That was fun. And yeah, you could compile Pascal code with a C compiler. It was hilarious. We loved it. And COBOL didn't innovate anything that anybody even wants to think about today, because it was just terrible. So I equals I plus 1, yeah, in COBOL is add 1 to I giving I, because they thought that was better. So what they actually thought was, if we make it as close to English as possible, ordinary business people will be able to write their own software. It will be the end of programmers. And so when people say things like AI assistant are going to be the end of programmers because the business people will just be able to talk to the AI and write their own, no, they won't. No. Business people are never going to be able to do what we do, in the same way that most of us can never do what they do, which as far as I can tell is wearing ties and pretending to be grown-ups. I'm not going to do either of those things. I'm just going to carry on doing these silly bloody talks and hope they entertain people. So I hope it entertains you, Øredev. Enjoy the rest of your day, enjoy your lunch, and come and find me if you want to talk more geek stuff. Thank you.